Okay, hello everyone, welcome back. So today we are going to solve some numerical problems or some MCQs we are going to solve based on our previous taught topic, that was Newton's first law and second law of motion, and this includes the momentum also. Okay, so let us start with the first question. Okay, now what does first question say? And the momentum measures the amount of what? It measures the amount of motion, obviously, because we said that the momentum is what? Momentum is the product of the mass and velocity, and it measures the motion of the body. Force measures rate of change of linear momentum, so our answer will be C. CGS unit of force is CGS unit of force. In CGS in SI unit, we had written the Newton as the in SI unit we have written Newton as the SI unit. So its unit was, its value was kilogram meter per second square. Now if we have to convert it in CJ system, then kilogram will be converted in gram, meter will be converted in centimeter, and second will remain as it is. So it will be second square. So what does this called? This was called dyne. We have already studied these things. So our answer will be dyne. Momentum has same unit as momentum, and impulse has same unit. What is impulse? Impulse is the, if a large amount of force is impacting for a smaller time period, then it is known as impulse. So suppose that a force of F is acting for a small time of period, that is t, then what will be impulse? Impulse will be force multiplied by time. Suppose that if we have to give the examples of the impulse, then we can consider that if we use hammer to if we use hammer to nail to hammer down a nail into the wall, then we apply a large amount of force by the hammer on the nail head, and it penetrates into the wall. So we are basically giving the impact of hammer to the nail, है ना? जो दीवार में कील ठोकते हैं, तो कील ठोकने के लिए हथौड़े से जो हम उसके ऊपर वार करते हैं, दैट इज इम्पल्स. सिमिलरली, if a fielder catches a ball in a cricket match, if a fielder is catching a ball, then at that time what does he do? He lowers his hand, है ना? While catching the ball, he lowers his hand. Why do he do so? Because when he catch the ball, the amount of force that may hurt his hands. So to lower the amount of impact, he increases the time period by lowering his hand. Okay, we will discuss it later. Now next question. When force of 1 Newton acts on the mass of 1 kg, which is able to move freely, the object moves with a or an speed or acceleration. It will move with an acceleration of 1 meter per second square. We have defined the value of 1 Newton as if 1 kg of mass is being accelerated by 1 meter per second square, then the applied force will be equals to 1 Newton. Similarly, in opposite way, if we are saying that 1 Newton of force is being applied on a mass of 1 kg, then we will say that the body will accelerate with the 1 meter per second square acceleration. Next question. The net force acting on a body of mass 1 kg moving with a uniform velocity of 5 meter per second. It is asking for the uh, net force. We have been given a mass of 5 kg and its velocity uniform. It says the uniform velocity of 5 meter per second. Now if since there is no rate of change of velocity, since there is no acceleration, we will say that there is no force. If there is no force, then the 0 Newton will be our answer. Next question. A body of mass 20 kg moves with an acceleration of 2 meter per second square. The rate of change of momentum is SI unit. In SI unit is rate of change of momentum in SI unit. We have to find out. What does it say? Mass is given 20 meter per 20 kg. Here let us write m is equals to 20 kg and moves with an acceleration of 2 meter per second square. A is given as 2 meter per second square. Now he is asking the rate of change of momentum. We have already studied that the rate of change of momentum is known as force. So F is equals to simply mass into acceleration. So mass is 20 and acceleration is 2. So our answer will be 40 newtons. So A will be our answer. Next question. A body of mass m strikes against wall with a velocity of v and rebounds with the same velocity. Its change in momentum is. Now, suppose that here is a surface of wall. Let us say this is surface of wall. Okay, and okay, and this is the ball. It strikes the wall and then it rebounds. Here it has not given any direction, so we will consider that the ball has the same direction, or we will say that it rebounds in the same line. Okay, so if it is rebounding in the same line, now momentum, we have said that the momentum is also a vector quantity. So if we are considering the net change, then what will we do? Final momentum minus initial momentum. Its final momentum has opposite direction. Look, it's finally rebounds in the opposite direction na? So we will take m into v as negative, but when it was initially coming with the mass and m and velocity v, its momentum was m into v mv. So change in momentum delta p will be delta p minus of final momentum, that is minus mv, then minus of initial momentum, that was mv. So how much it is? It has become, it has become minus of 2 mv. So our answer will be minus of 2 mv. So D will be our answer. Now gram weight is a unit of obviously weight. 9.8 Newton is equals to, okay, 9.8 Newton. Let us see. There is another unit of force that is known as kilogram force or simply kilogram weight. So what is kilogram force or what is kilogram weight? It says that a mass of 1 kilogram, a mass of 1 kilogram is being accelerated by the gravitational acceleration. So what is this gravitational acceleration? Its value is 9.8 meter per second square. So it says that if a body of mass 1 kg is being accelerated by 9.8 meter per second square, then we say that there is acting 1 kilogram force or 1 kilogram weight of force. So this is equals to what? How much force, if we have to calculate that how much in Newton terms, how much force is there, we will say 1 into 9.8 or simply 9.8 Newton. Okay, understood? So if the question says that 9.8 Newton is equals to, now it's, we have to reverse the equation, we have to reverse the formula. Then what we will say? We will say 9.8 Newton is equals to 1 kilogram force, but this kilogram force and kilogram weight both are similar, means both the terms are same. So what we will say? Its answer will be both A and B. Next question. A body of mass 5 kg undergoes a change in speed of 20 meter per second to 0.2 meter per second. The momentum, now we have to check the change in momentum. So let us first delete all this. Okay. Now what it is saying? We have to find out the change in momentum. So delta p will be final momentum minus initial momentum. So final is 5 kg, mass is same, we will say 5 kg is mass, and final velocity is 0.2. Then we will minus initial, that was 20 meter per second, 5 kg of mass with 20 meter per second. So how much it come? 5 into 0.2, that is 1, minus this is 100. So change in momentum is minus of 99 kilogram meter per second. So minus 99, it has dropped, that means 99, it is, it has been decreased, it has been decreases by 99 kilogram meter per second. So our answer will be B. Next question, the combined effect of mass and velocity is taken into account by a physical quantity called. Combined effect of mass and velocity is known as momentum, obviously. So answer will be C. How many dynes are equals to 1 Newton? We have solved it. 1 Newton equals to 10 to the power 5 dynes. Choose the correct relation. Acceleration equals to force upon mass. We have seen that F is equals to mass into acceleration. So if we have to calculate the acceleration, then we can say A is equals to force upon mass, isn't it? So our first relation is correct. Okay. Like this we will solve all these questions. Now we will end our today's video here. In next videos we will move further. Okay, till then, thank you.